Welcome again. This is our lesson 2. The first one I did was electricity 2. Now I'm doing electrostatics 2. The key formula is capacitance is equal to charge per unit volt, Q over V. We have this diagram again from KMF. You will get it somewhere. KMF. I'm using it to illustrate key things. Now, look at my right hand side here. When you're dealing with the resistors, total resistance of resistors in series is the sum of individual resistors. But when I want total resistance of resistors in parallel, I take their reciprocals. It is opposite in capacitors. It is opposite. So, if you know one very well, do cross multiplication. The one which is on the left goes down bottom. The one which is on top up comes down left bottom. Simple. Or devise your own way. So we come here. If we have this diagram, just like in resistors in electricity, start with a combination of parallel. So how can we get this? One capacitor which replaces B and C. This is simple now. In capacitors is the sum of capacitance. So total capacitance in parallel is the sum. So these will be replaced by a single capacitor whose value is 8 microfarad. Correct? So here I have one, which is, I can give it name D. D, if we have to move together. So there is D which has replaced B and C. D and A will be in series. So effective capacitance in series, see, this is like A if you are following, and this is D. So these ones, they are in series. You do the reciprocal here. 1 over CT is 1 over 4 plus 1 over 8. You get 8 over 3. This is not the answer. Never stop there. Most of you stop there. So here, 1 over CT is equal to that. Hence, CT is equal to that. Now, this 8 over 3 microfarad replaces these two again. So I've remained with only 1. Just like you'd get effective resistance. If you have V and you have R, you should get what? I. Now, the same thing. You have total capacitance. Then you have voltage. You should get current. And if you understood current, how it flows in resistors, pick it. It is an analogy. That is how it will behave in capacitors. But the wording will be different. Okay? So this is the effective. Anytime I reach there, I must get Q. Q. It's okay? So charge is equal to C times V. In other words, if it was resistor, you will be asked, what is the current flowing in the circuit? What is the current from the source? They'll ask you what is the current from the source. But here they will give you what is charge in a component. Okay? Just check here. If I have this source and I have resistor here and I have another one here, like that. Now listen. The current from the source comes, is the same which will flow there, is the same which will flow here, and back to the source. But we don't tell you current flowing. We ask you what will be charged either in X or what is charged in Y. What is charge in X? What is the charge in Y? Okay? So here I've asked you, what is the charge in capacitor A? What is the charge there? It is as good as getting the charge from the source, in bracket, charge from the source. Why? We only talk of current from the source. But you are okay. So Q is equal to CV. Okay? Our total capacitance is 8/3. The source voltage is 12. You get 32 microamperes because our capacitance was in microfarad. You can simplify to that. Okay? Keep on moving. Focus down a bit here now. Focus down here. Now, suppose I ask you, what is the PD across A? And what is the PD across BC? Remember, BC gave us BC gave us D. B and C gave us D. So I could have asked you, what is the charge of capacitor A, or what is the charge of capacitor D? D replaced B and C. Now I'm trying to jog your mind. What is the PD across A? PD from our formula. Here, formula. Capacitance is equal to Q over V. Therefore, V is equal to Q over C. If I get the PD across A, subtract it from 12, I should get PD across D. D replaced B and C. Okay? Now you come here. Okay? We know the charge. Here, 32. The charge, 32 microamps. Okay? Then we divide by the capacitance. We are talking of A. Capacitance is 4 microfarad. Focus again down. Charge is 32 times 10 to the power -6. Divided by capacitance, that you get 8. So automatically PD across D is 12, okay, of the source. 12 minus 8, you should get 4. But we want to do it. We want to do it. We want to enjoy. We want to do it. So what is PD across D? Okay? What is the PD across D? 32 times 10, that is charge, divided by capacitance. What was the capacitance that replaced B and C? That is capacitance of D. Focus again up. It was 8. So I divide by 8. 32 divided by 8, you get 4. Of course, these ones will cancel. So we are very right. Try up to that level only. Understanding current operation in resistors and current operation in capacitors. Don't eat too much. You want to know everything one day. No. You are told even Ndewa was not built in one day. But since they were in Europe, they said Rome. Bye-bye.